Java remains one of the most widely used programming languages in the tech industry. Its reliability, scalability, and performance make it a top choice for enterprise-level applications and backend systems. Many leading companies rely on Java for their core infrastructure, and its versatility ensures that developers of all levels can find opportunities to work with it. In this video, we'll walk through essential core Java interview questions, suitable for both freshers and experienced professionals. Whether you're preparing for your first interview or brushing up your skills, this guide will help you revise key concepts and boost your confidence. One of Java's most celebrated features is its platform independence. Unlike many programming languages, Java compiles code into bytecode, which is stored in a class file. This bytecode can run on any operating system or hardware as long as a Java virtual machine, JVM, is installed. The JVM interprets the bytecode, making Java programs portable and flexible. Although the JVM itself is platform-dependent, the bytecode can be executed anywhere, ensuring consistent results across different environments. This feature is a major reason why Java is preferred for large-scale, cross-platform applications. Java's popularity is rooted in its rich set of features. It's simple to understand, with clear syntax that makes learning easy. Platform independence allows the same program to run on any software or hardware. Java is both interpreted and compiled, offering robust performance. Features like garbage collection and exception handling make it robust. Being object-oriented, Java supports classes, objects, and the 4 pillars of OOPS. Security is enhanced by sharing applications without exposing the actual code. High performance, dynamic loading, distributed computing, multithreading, and architecture neutrality round out its strengths. The Java Virtual Machine, or JVM, is a core component of Java's architecture. It acts as an interpreter, loading, verifying, and executing bytecode. While JVM is platform-dependent, meaning its software varies across operating systems, it is crucial for Java's platform independence. The JVM ensures that bytecode runs consistently, regardless of the underlying hardware or OS. Understanding JVM is essential for any Java developer, as it impacts performance, security, and portability. The JVM also manages memory and provides a secure execution environment for Java applications. Just-in-time, JIT compiler is a part of the Java Runtime Environment (JRE) and plays a vital role in enhancing Java application performance. When Java source code is compiled, it becomes bytecode, which is then passed to the JVM. The JIT compiler, embedded within the JVM, compiles bytecode into native machine code at runtime. This process is activated when a method is invoked, allowing the JVM to call compiled code directly instead of interpreting it. As a result, execution speed and performance are significantly improved, making Java applications more efficient. JVM manages several types of memory storage to ensure efficient execution of Java programs. The class method area stores class-level data, including runtime constant pools and method code. The heap is where objects are created and stored, providing dynamic memory allocation during runtime. The stack holds data and partial results needed for method returns and dynamic linking. The program counter register keeps track of the current instruction being executed, while the native method stack stores native methods used in the application. Understanding these memory areas helps developers optimize performance and troubleshoot issues. The ClassLoader is a crucial part of the Java Runtime Environment. During execution, it dynamically loads Java classes and interfaces into the JVM. This dynamic loading means Java's runtime system doesn't need to know about files or file systems in advance. ClassLoaders make it possible to load classes on demand, supporting modular and flexible application design. Understanding how ClassLoader works is important for managing dependencies and optimizing application startup times. Understanding the differences between JVM, JRE, and JDK is fundamental for Java developers. The JVM, Java Virtual Machine, interprets bytecode and is platform-dependent, but enables Java's platform independence. The JRE, Java Runtime Environment, is an installation package that provides the environment to run Java programs. The JDK, Java Development Kit, includes development tools and the JRE, allowing developers to both develop and execute Java applications. Knowing these distinctions helps in setting up the right environment for development and deployment. Java and C++ are both powerful languages, but they differ in several key aspects. Java is platform-independent, while C++ is platform-dependent. Java is mainly used for application development, whereas C++ is often used for system programming. C++ is closer to hardware, supporting global scope and pointers, while Java avoids these for security reasons. Java uses a single root hierarchy, with all classes derived from java.lang. object and supports single inheritance trees. Understanding these differences is important when choosing the right language for a project. In Java, the main method is declared as public static void main string args. Each keyword has a specific purpose. Public makes the method accessible globally, allowing the JVM to invoke it from outside the class. Static means the method can be called without creating an instance, saving memory. Void indicates the method doesn't return anything. Main identifies the entry point for the program, and string args stores command line arguments. This structure ensures that Java applications start correctly and handle input efficiently. The Java string pool is a special area in heap memory where all string literals are stored. When a new string is created, the JVM checks if it already exists in the pool. If it does, the same reference is used. Otherwise, a new object is created. This mechanism optimizes memory usage and improves performance. Variables storing strings are kept in stack memory, while the actual string objects reside in the pool. Understanding the string pool helps developers write efficient code and avoid unnecessary object creation. Declaring the main method as static is essential in Java. While you can declare it without static, the JVM won't recognize it as the entry point, and your program won't start as expected. Static allows the JVM to invoke the main method without creating an instance of the class, ensuring efficient memory usage and proper program execution. This convention is a fundamental part of Java application structure. Packages in Java are used to group related classes and interfaces, providing access protection and namespace management. By organizing code into packages, developers can prevent nomming conflicts, control access, and make searching and usage of classes easier. Packages also allow for hidden classes that are not visible outside the package, supporting modular and maintainable code. Defining packages in Java offers several advantages. Packages avoid name clashes, provide easier access control, and allow for hidden classes that are only visible within the package. They make it easier to locate related classes and support better organization of code. By using packages, developers can build scalable and maintainable applications with clear structure. Java supports two types of packages: user-defined and built-in. User-defined packages are created by developers to organize their own classes and interfaces. Built-in packages are provided by Java, containing standard classes and interfaces for common tasks. Understanding the distinction helps in structuring projects and leveraging Java's extensive library ecosystem. Java has two main categories of data types: primitive and non-primitive. Primitive data types are single values with no special capabilities, including Boolean, byte, char, short, int, long, float, and double. Non-primitive data types, also known as reference types, include strings, arrays, classes, objects, and interfaces. Primitive types store actual values, while reference types store memory addresses. Understanding these distinctions is crucial for effective memory management and program design. The byte data type in Java is an 8-bit signed 2's complement integer, supporting values from -128 to 127. It's used when memory savings are important and the range of numbers needed is limited. Byte is ideal for situations where large numbers aren't required, such as working with raw data streams or low-level file operations. Java does not support pointers, unlike languages such as C or C++. This design choice enhances security, as pointers can lead to unsafe memory access and vulnerabilities. By avoiding pointers, Java ensures safer and more reliable code, making it suitable for enterprise applications where security is a priority. In Java, the default value for the byte data type is 0. This means that if a byte variable is declared but not initialized, it will automatically be set to 0. Understanding default values helps prevent unexpected behavior and ensures consistent program execution. For float and double data types in Java, the default values are 0f and 0d respectively. These defaults ensure that uninitialized variables don't contain garbage values, supporting reliable and predictable program behavior. Wrapper classes in Java encapsulate primitive data types, allowing them to be treated as objects. Java provides 8 wrapper classes: Boolean, byte, short, integer, character, long, float, and double. Wrapper classes are final and immutable, offering methods like valueOf and parseInt, and supporting features such as autoboxing and unboxing. Custom wrapper classes can also be created, similar to structures in C. Wrapper classes are essential in Java for several reasons. They provide object representations of primitive types, enabling use in collections and frameworks that require objects. Wrapper classes are immutable, offer useful methods, and support autoboxing and unboxing, making code more flexible and easier to work with. Instance variables are declared outside methods and belong to the class, while local variables are declared within methods and only accessible during method execution. Instance variables have default values and can be used throughout the class, whereas local variables do not have default values and their scope is limited to the method. Java assigns default values to instance variables based on their data types. Numeric types default to 0, Boolean to false, object types to null, and char to the null character, \U0000. This automatic initialization helps prevent errors and ensures consistent behavior when variables are not explicitly initialized. Class variables, also known as static variables, are declared within a class but outside any method. They are shared by all instances of the class and exist only once, regardless of how many objects are created. Static variables are useful for storing values common to all objects, such as counters or configuration settings. Local variables in Java do not have default values. Primitive variables and objects declared within methods must be explicitly initialized before use. This requirement helps prevent accidental use of uninitialized data and supports safer programming practices. Instance variables are unique to each object and are not shared between instances. Class variables, declared with the static keyword, are shared by all objects and the class itself. Understanding the difference helps in designing classes that manage shared and individual data efficiently. Static variables in Java are shared among all objects of a class. Once declared, only a single copy exists, making them ideal for values that should remain consistent across instances. Static variables are commonly used for constants, counters, and configuration settings. Java provides 3 standard streams: systemout for outputting data to the console, systemer for displaying error messages, and systemin for reading input from the terminal. Systemout and systemer are print streams, while systemin is an input stream. Understanding these streams is essential for handling input and output in Java applications. Java's I/O package brings various streams to perform input and output operations. Streams support all types of objects, data types, characters, and files, enabling comprehensive I/O functionality. Understanding streams is key to managing data flow in Java applications. Reader and writer classes handle character data, while input stream and output stream classes manage byte data. Reader-writer classes accept character arrays, supporting Unicode and internationalization. Input-output stream classes accept byte arrays and are used for binary data. Choosing the right class hierarchy ensures efficient data handling. Stream classes in Java are divided into byte stream and character stream types. The supermost class for input stream is Java.io, input stream. For output stream, it's java.io, output stream. For reader classes, it's java.io, reader, and for writer classes, it's java.io, writer. Knowing these hierarchies helps in understanding inheritance and stream functionality. File input stream is used to read data from files as a stream of bytes, ideal for binary data like images or audio. File output stream writes data byte by byte into files, commonly used for saving raw data. These classes provide low-level access to file operations, supporting efficient data management. Buffered input stream and buffered output stream classes enhance I/O performance by buffering data before reading or writing. Buffering reduces the number of interactions with the disk or network, allowing programs to handle large amounts of data efficiently. Using buffered streams is recommended for high-performance applications. Filter streams in Java return a stream consisting of elements that match a given predicate. They don't perform filtering directly, but create a new stream for traversal. Filter input stream and filter output stream are used to process data in a flexible and efficient manner. An I/O filter is an object that reads from one stream and writes data to input and output sources. Java's I/O package provides classes to implement filters, enabling advanced data processing and transformation during I/O operations. Java offers multiple ways to take input from the console: command line arguments, buffered reader, console class, and scanner class. Each method has its advantages, and choosing the right one depends on the application's requirements and complexity. Java provides 3 methods for output: print, println, and printf. The print method outputs data and keeps the cursor on the same line. Println moves the cursor to the next line after printing. Printf allows formatted output using format specifiers, making it ideal for structured data display. Operators in Java are special symbols used to perform operations on variables and values. Java supports various types of operators, including arithmetic, unary, assignment, relational, logical, ternary, bitwise, shift, and instance of. Understanding operator precedence and usage is key to writing effective Java code. Java provides 9 main types of operators: arithmetic, unary, assignment, relational, logical, ternary, bitwise, shift, and instance of. Each operator serves a specific purpose, from mathematical calculations to logical comparisons and data manipulation. The operator shifts sign bits, while shifts zero-filled bits. This distinction affects how negative numbers are handled during bitwise operations. Understanding these operators is important for low-level data manipulation and optimization. In Java, the assignment operator equals is the only right associative operator. This means expressions are evaluated from right to left, which is important when chaining assignments or initializing multiple variables. The dot operator in Java is used to access instance variables and methods of class objects. It also allows access to classes and subpackages from a package, supporting object-oriented programming and modular code design. Covariant return type allows overriding methods in child classes to return a subtype of the parent's return type. This feature avoids confusing typecasts, improves code readability, and helps prevent runtime classcast exceptions. It's a valuable tool for creating flexible and maintainable code hierarchies. The transient keyword is used during serialization to prevent certain variables from being saved in a file. When a variable is marked transient, the JVM ignores its original value and saves the default value for its data type. This is useful for sensitive or temporary data that shouldn't be persisted.